We should interpret the significant interaction first. Okay, I don't know if you would wonder, like, why? Main effect seems so important. They're the main results. Why are interactions interpreted first? Because interactions give you the details of the exceptions of certain relationships. So we said if there's a significant interaction, it's like adding the word "it depends." Like, what's the relationship between this and this? I can tell you, but it depends on different type of people or different type of groups, which is based on the other variable. So if it depends, we don't have a universal relationship between that certain variable and the outcome variable. So I'll give you some examples. So there's three possible misinterpretations. One is called spurious no main effect, attenuation of main effect, non-spurious, non-attenuated main effect. As you see, I can't even read it clear, so it might be a little bit confusing, but we'll use some charts, graphs to explain this. So let's say this was our research question. Is CBT or humanistic approach better at treating social anxiety clients? So we have recruits a bunch of people that are dealing with social anxiety. We assign them to CBT and humanistic. And then after they receive their intervention, their treatment, afterwards we measure their social anxiety score. So based on this chart, okay, we just combine all the participants, and so that's a main effect. We don't consider gender, so that's a main effect. So we see CBT, they have a 28 score on social anxiety, and humanistic folks also have a 28 score. So what's the result of this main effect? There's no difference, right? However, if we break them down into men and women, this is what men looks like. This is a made-up example. So men who receive CBT now has a 20-point score on social anxiety compared to those who receive humanistic that has a 36. So for men, CBT seems to work better with social anxiety than humanistic approach. However, for women, it's totally opposite. So those that get humanistic approach, they score a 20, and those that receive CBT scored a 36. So in this made-up example, they're totally opposite, but when we take them all together, they cancel out each other. So there's no difference between the two. So this is called a spurious, how do you pronounce this? Spurious no main effect situation, that you don't see any main effect because they totally cancel out each other. Okay. So like in this example, it wouldn't be helpful to talk about there's no main effect, right? Because they differ so much by gender. We're more interested in knowing about, okay, so how does it work for men? How does it work for women? Because they differ so much. It's not really helpful to know, oh, CBT and humanistic doesn't work. No, that's totally, we would be misinterpreting the results and masking the significance of the difference between the two. So this is one example. And this other example is called attenuation of main effect. So based on all the people, we see that there's a difference. Humanistic seems to not work as much, as good as CBT. So CBT, the post-treatment social anxiety is 26, humanistic 30.5. So based on eyeballing, we see that, okay, there's a slight difference. CBT outperforms humanistic by a little bit. But if we look at men and women, we see, okay, CBT and humanistic, okay, they differ even more. CBT outperforms humanistic even more. But for women, it's the opposite. Humanistic outperforms CBT, but not as much as the strength for men compared to two. So when we combine them together, this washes out a little bit of this, so then it becomes sort of like this. Does that make sense? We still see some sort of main effect, but if we simply only reported this main effect, like CBT is a little bit better than humanistic, it doesn't really make much sense, because for men, CBT is much better than humanistic, but for women, humanistic is better than CBT, but when you cancel out the two, there's, CBT is slightly better than humanistic. So it's still, it's not that helpful to report the main effect. But we can still report it, but I think the focus is on the significant interaction and what that looks like. Okay, and then this is a third one. This is a more common one that we see, and this is kind of like a moderation in regression, except it's for continuous variables. It's called a non-spurious, non-attenuated main effect. So here's CBT and humanistic. Humanistic seems to not perform as well as CBT. But if you break it down into men and women, okay, for both groups, CBT is better than humanistic, but the difference between those two are more profound for men than for women. So this is another example. They are in the same direction, but the level of difference, degree of difference, is different across these two groups. So there could be interactions like this. The direction is the same, but the degree of difference is different across the two groups. Okay, any questions about these? So the conclusion is, let's focus on the interaction, if there is an interaction effect, and that would be the suggestion. But you can still report. I would like for the homework assignment, you will still report the results, the F of the main effect. But when you're explaining things or making it, interpreting the results, focus on the interaction, if there is an interaction effect. So next, what we will do is we're going to talk about higher order factorial ANOVA. But this is going to be a more complicated situation. We're going to deal with 3 different IVs now. Before it was 1 IV for one way, for two-way it was 2 IVs. Now we have 3 IVs. So this is what it looks like from a calculation standpoint of view, but we're not going to calculate it, but just want to give you a conceptual sense of the different components involved in a 3-way ANOVA. So there's the main effects. So there's 3 IVs, A, B, and C. So there's 3 main effects, A, B, and C. And then there's interactions. So think about interactions as possible pairs of variables together. So you have A and B together, A and C together, B and C together. So that's 3 two-way interactions. And then there's also 1 3-way interaction. That's putting A, B, and C together, just accounting for all 3 variables together at the same time. So for a 3-way ANOVA, we have 7 different omnibus results that we'll be reporting, and 3 main effects, 3 two-ways, 1 3-way. So that's something that would be important for you to kind of know, like know how many 2-ways there will be, how many 3-ways there'll be. So just to refresher, like if it was a 2-way ANOVA, how many 2-way interactions will we have? One, yeah, we'll only have 1 because we have that 2 variables. There's only 1 pair. So for 3-way, we have 3 variables, A, B, and C. And so we have A and B, A and C, B and C. So we have 3. So if we had a 4-way interaction, 4-way.
You said it's a bad research design.
Yes, it'll be really hard to explain. And I think it's very, very complicated. So it would be 3 plus 2 plus 1. So 6, right?
Yeah.
B plus 2 plus, yeah, so we'll have 6 different 2-ways, and then we will have 3-ways. That probably will be 3 of them, I think. And then we'll have 1 4-way interaction. So we'll have, I don't know, over 10 different F values. But no way we're gonna do a 4-way. And I think it would be really bad design, or trying to fish for things if we're doing 4-way, unless somehow it's so important we can conceptualize a complicated, sophisticated project like that. And so one more thing that would be important for you to know is how to calculate the degrees of freedom. So for the A, B, C main effects, the between group degrees of freedom, it's the levels minus 1. So if there's two groups, it's 2 minus 1, we have 1. And B and C, similar formula. And then for the interactions, it's similar to the two-way interaction. It's the A minus 1 times B minus 1. So if we have A, there's 3 groups, B, we have 2 groups, so it'd be 2 times 1, so it'll be 2. And the three-way would be the product of A minus 1, B minus 1, C minus 1. And then for the error or the within group, it's N minus A times B times C. So just a refresher, for the two-way, the error was N minus A times B. And then the two-way, the interaction was also A minus 1 times B minus 1. So it's a similar pattern, but that will be how you calculate, figure out the degrees of freedom. Okay, and how do we display or present the results, or what does it, conceptually, what does it look like? So we have 3 variables, A, B, and C. So we would have to use one variable and then split them into half. So it'll be like looking at a two-way interaction under the condition of C1, and then looking at the two-way situation under the condition of C2. So that will be how it looks like. We'll just split the results based on one of the variables and look at the interaction effect. So it's sort of breaking down the three-way into 2 ways, 2 different two-ways. I'm going to talk about issues with unequal n, and this is a little bit more technical, so bear with me if it's really hard to understand, and I will tell you the main points that are important for you to take away from this. Okay, so if I were going to do an experiment, and the goal was to see what factors affect the lowering of cholesterol levels. Okay, one factor that we're testing is whether you have exercise or not. So we assign a group to do moderate exercise, a group to not have exercise. And the other factor is we want to look at whether diet affects the lowering of cholesterol. And then we assign a group to eat low-fat diet and a group to eat high-fat diet. Okay, so these are the results. So actually it turns out that we only got people to be in either this group or this group. So there's this group that were in the exercise and low-fat group, and these are the level of cholesterols that they were able to lower. So it ranged from 15 to 35. And then we had this other group that did not exercise and had a high-fat diet. And this is their cholesterol change. There was one that lowered it by 20, but there's 6, like increased by 6, increased by 3. So these are the results. So to answer this question, first what we can do is we want to see if diet has an effect. So what we do is we calculate the means. Okay, so those on low-fat diet, they're on average, their mean level, their cholesterol level decreased by 25. And those on high-fat diet, their cholesterol decreased by 5. So does that mean low-fat diet is a factor that leads to cholesterol decrease? Yes? No? Not sure. No, right? It doesn't mean that, because we don't know if the results of this decrease is because of low-fat diet or because of exercise. The 2 variables are confounding. So this is why sometimes in ANOVA we talk about equal sample size. Are you missing certain cells? Because if you're missing certain cells, the factors get confounded. You can't really attribute the result to one independent variable because of a situation like this. So that's the one takeaway message. We don't know if lowering of cholesterol is associated with exercise or diet because those two are completely confounded. So that is a complete confounding situation. And here's a situation where, okay, we do have some participants in each cell, but they have different sample size. So in this situation, we have a bunch of people in moderate exercise, low fat, non-exercise, high fat. But in non-exercise, low fat, we only have one. In moderate exercise, high fat, we only have one. So we can calculate the means in two different ways. One way is calculate the weighted mean, and the other way is the unweighted mean. Let me explain what they are. So one way of calculating the mean of low fat is to just take all these variables, added them up, and divide them by 5. So if we add this up, divide by 5, we'll get a negative 26. And why is this called weighted? Because when we calculate the mean, we take 4 from the moderate exercise group and only 1 from the non-exercise group. So it's weighted more stronger towards the moderate exercise group. As we can see, the 26 is much closer to the 27 than to the 20. So if we do weighted mean calculation, we ignore the effect of exercise. And to account for that, we would do unweighted mean. And instead, what that means is we would calculate the mean based on having the same weight between whether they do exercise or not. So that's actually the mean between 27.5 and 20. So we use, even though this only has one participant, but the weight is the same. So we calculate the average between this and this, or we times 20 by 4 times and then do the whole thing. So as we see, the weighted, unweighted means here is kind of between the two. Does that make sense? So this will account for the effect of exercise. So what you needed to know is weighted means ignore the effects of other variables and can result in confounding. However, if you want to control for that, it will be important to use unweighted means. And in terms of SPSS, if you look back, the results that we've done with ANOVA and two-way ANOVAs, three-way ANOVAs, they're all type 3 sum of squares. That's the default type of sum of squares that's calculated. And it's one form of unweighted means. And then type 1, type 2 are weighted means for different purposes. If we want to prioritize the order of the effects or whether to have equal order of the effects. So you don't need to know all the background ins and outs about those. I don't know it either. But just to know that the default in SPSS is type 3 and the difference between unweighted means and weighted means. That makes sense. So if we want to account for the other variable to minimize confounding, we want unweighted means. So the different types, type 1, type 2, type 3, it accounts from a statistical standpoint. So it takes the numbers, unweights them, and which can account for some of the confounding effects. But one last thing that I want to note is that sometimes if the confounding effect is part of the research design, then it won't be helpful, it won't be useful to account it for the different types. So as we see, if you use type 1 or type 2, it's in situations when it's non-experimental designs. So let me give you a scenario. So if our research study was to see, okay, if we have, we're interested in anxiety about public speaking. Okay, and then we want to see if people who are asked to talk about an embarrassing thing in their public speaking task, would they be more anxious than those who were just asked to talk about a random topic? in public speaking. So we assign people to two different conditions. One is to do public speaking and to talk about the most embarrassing thing that have happened to them. And then we assign another group of people to talk about their last meal, what they had. So that's a random subject. And based on this, we recruit people. We recruit 20 people. We assign 10 to embarrassing topic, 10 to their meal. And when we actually run the experiment, all 10 of them show up, those that were asked to talk about the meal, but only 4 out of 10 showed up for the embarrassing assignment. Okay, so we have missing data there. So do you think the missing is at random, or it might be related to the design? Design, right? People who are asked to talk about embarrassing things might have a different reaction than those to speak in public about their last meal. So that confounding factor is in the design itself. So it wouldn't be something that we could easily account for in stats. Does that make sense? So in terms of experimental design, a lot of times when we publish articles, we need to talk about missing data. Is it missing at random, or is it missing with a certain pattern? So based on this situation, it seems to be missing with a certain pattern. We had a lot more missing data, and only missing data in the group that was asked to talk about embarrassing events, but not when they were talking about the random, like their meal. So if it was equal, then we could say, okay, maybe it's just missing at random. People had things, couldn't show up. But in this situation, it wasn't, so we can't easily just use stats to account for that. It's a deficit or a limitation in the design issue.